Live streaming is on.
All right. Good morning, ladies and gentlemen. We're going to go over the worksheet one on work, and just going to get going on that. There we go. And how do we maximize? Nope, that's not quite what I wanted. Get this figured out just a second. Sorry, ladies and gentlemen. There we go. I think that's better. All right, so this is Science 10 worksheet 1. So let's take a look and see where we can go. That's not what we wanted. There we go. There we've got our worksheet. So hey, we could call this the key. Now it would be helpful to pick up a pen and key. Here we go. So work is the product of the blank exerted an object and the distance the object moves in the blank of the force. Well, so if we go back just to review, we have F is equal to mg. That's the force of gravity and the mass times the gravitational field strength. And then we were using a circle. Not that the shape is important by any means, but it just gives a way of differentiating that these things are different. That work is equal to the force times the distance. So work is the product, multiplication of the force exerted on an object and the distance the object moves in the direction of the force. Because remember, we talked about the idea of picking up something up the back of the truck and carrying it, or dragging something off the back of the truck going up some stairs. And even though you walk horizontally, when your force is upwards and your distance is at 90 degrees, there's no work. It's your force has to be in the direction, the distance has to be in that direction, then there is work. Here there is no work. The equation for work is, so work is equal to force times distance. The unit for work is, well, the unit for work comes from the unit of force, which is newtons, and the unit for distance or displacement, which is meters. The unit for work is Newton meters, which is also called the joule. Oh, We've talked about these being alternate units for this. Work is done by an object only if the object moves. So if you are standing and you're here and you're pushing against a wall and the wall's not moving, no work. Work is done on an object only if the force and displacement are in the same direction. Just trying to get you to go through. All right, so let's go back to our pointer and we can do this, but then we have to erase this, yeah. Okay, back to our pointer. Let's take a look at the next one. For each problem, draw a diagram and make sure the force and displacement are in the same direction. There we go. A person lifts a package weighing 75 newtons. If she lifts it 1.2 meters off the floor, what work has she done? All right, so here's the package. And she has come in and she's picking this up and she's lifting it up. And the force, well, we know that there it has 75 newtons. That's the force of gravity pulling it down. So that's going to be our force that we're going to use. The distance, well, she takes it 1.2 meters. What work has she done? Well, these are the values that we have. Work is what we're trying to find. Work is equal to force times distance. So that's equal to 75 newtons times our 1.2 meters. So pulling out the Casio FX260 Solar, 75 times 1.2, that's equal to 90 Newton meters or 90 joules. When 142 joules of work is done pushing a box horizontally 13.3 meters, how much force is applied? All right, so here we have our flat ground. Here we have our box and we're pushing it. And the distance traveled is 13.3 meters. And the work is equal to, well, so we have 142 joules. So that's our work. We have our distance, which is 13.3 meters. And we're trying to find the force. So if we take a look at our equation, work is equal to force times distance. If we're looking for force, we cover up force, and so force is equal to our work divided by our distance. So we're going to take our 142 joules of work, divide that by our 13.3 meters, and we'll find that our force is equal to 142 divided by 13.3, and that's equal to 10.7 newtons. All right. Let's erase this. Isn't this exciting, watching stuff being erased on your screen? All right. This brings us to our last question. What work is done when a person pushes a refrigerator weighing 720 newtons across a 12-meter floor? Floor 12 meters, the force of friction between the refrigerator and the floor is 480 newtons. I'm going to draw my picture up here. So we've got this, and we have our refrigerator. And we've got this person, and they're pushing the refrigerator, and they're pushing it with 720 newtons, and it travels a distance of 12 meters, and there's a force of friction of 480 newtons. What work is done when a person pushes a refrigerator? So the work done isn't going to care about how much friction there is. It's going to care just about how much work, how much force they're putting into the situation. So work is equal to force times distance. So our work will be equal to 720 newtons times our 12 meters. So our work is equal to 8640 Newton meters or 8640 joules. There we go. That's the answer down here. All right. I think that is the end of it. I'd like to say, have a great day. All right. Now I'm going to come over here and stop my live stream.